Hello, my name is Aniket Sharma. Let's start with the topic hydraulic machines here. There are two types of machine which we have to discuss here. First one is a turbine and second one is a pump. So turbine is a hydraulic machines which converts the hydraulic energy into the mechanical energy. Similarly, if we can say that the hydraulic machines which converts the mechanical energy into the hydraulic energy are called pumps. So there are the three types of turbine which we have to discuss: the Pelton turbine, Francis turbine, and Kaplan turbine here. In the classification of pump, we can say that there are the two types of pump: centrifugal pump and reciprocating pump. So let's start with the topic turbine here. So as we can say that there is a general layout of the hydroelectric power plant, and this is the figure which consists of a dam here, and dam is connected to the penstock which is laying a pipe. Generally pipe is a penstock. We can say that the penstock is a kind of pipe which is fitted to the dam and carrying the water to the tail race of the turbine. Turbine is fitted just above the tail race. We can say that there are the two head here. First one is a gross head and second one is a net head. So gross head can be defined as a head available to the power plant here, and net head is a head under which the turbine works. So there is all about the layout of the hydroelectric power plant. We have to show the net head here. If then H is equal to Hg minus the loss due to the friction, that is FLV square upon 2GD, that is due to the Darcy-Weisbach equation here. So we can consider the minor losses and major losses both here. The friction loss is basically a major losses, and the minor losses will be due to the bend, due to the sudden contraction of the pipe, due to the sudden bend of the pipe, or due to the sudden enlargement of the pipe. So next topic we have to discuss here, that the efficiency of turbine. So basically there are the four type of efficiency we have to study: the hydraulic efficiency, mechanical efficiency, volumetric efficiency, and overall efficiency. Hydraulic efficiency is basically can be derived as the eta H, that is equal to the Rp upon Wp, that is the power delivered to the runner and power supplied at the inlet here. So it is Rp upon Wp. Similarly, there are the main two concept here how we can calculate the Rp here. Rp is basically a power delivered to the runner, that is the runner power here. So if I am talking about the Pelton turbine, that is having the Rp is equal to this formula, Rp having this formula. And similarly, if I am talking about the radial flow turbine, that is Francis turbine, it is having this type of formula. We can easily see that it is using the small u here, and in a radial flow turbine it is used the different velocity u1 and u2. Later part we will discuss in a detail here. So in next we have a water power. What is water power here? So water power is defined in SI unit, that is rho GQH divided by the 1000 in kilowatt unit, and this water power equates to the QGH in kilowatt, or it is divided by the 1000 here. Next topic is the mechanical efficiency, that is the shaft power upon runner power. It means the power at the shaft at the turbine or power delivered at the water to the runner. Similarly, the volumetric efficiency here, the volume of the water actually striking to the runner here and volume of the water supplied to the turbine here. This is the very important here, the overall efficiency. So overall efficiency is the shaft power upon water power here. So we can use the shaft power upon water power with the multiplication and division of the RP, because we have to derive this type formula, that is overall efficiency is equal to the mechanical efficiency into hydraulic efficiency. So sometimes this formula is used in the numerical portion, or sometimes it is asked in the examination for the derivation also. So if I classify the different types of hydraulic turbine on the basis of the different criteria, so according to the type of energy at the inlet, that is impulse turbine and reaction turbine, and according to the direction of the flow, that is tangential, radial, axial, and mixed flow, and according to the head of the inlet, that is high head, low head, medium head, and similarly according to the specific speed here. So in the next topic here, we have to discuss the Pelton wheel or Pelton turbine, that is known as a impulse turbine also. So rest of all we will discuss in the next class.